Ensuring Scalability and Reliability with AWS ALB and Auto-Scaling, a comprehensive guide. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. In today's fast-paced digital landscape, ensuring that your applications are scalable and reliable is crucial. AWS provides powerful tools like Application Load Balancer, ALB, and auto-scaling to help achieve these goals. This podcast will explore leveraging these services to build robust, high-performing architectures. Introduction to AWS Application Load Balancer. ALB. AWS Application Load Balancer, ALB, is a managed service that distributes incoming application traffic across multiple targets, such as EC2 instances, containers, and IP addresses. ALB operates at the application layer, OSI model layer 7, and supports HTTP, HTTPS, and WebSocket protocols. This makes it ideal for distributing traffic for modern web applications and microservices. Key features of ALB: content-based routing, directs traffic based on URL, query string, headers, and HTTP methods. SSL termination, offloads SSL decryption/encryption to improve performance. WebSocket support, handles WebSocket connections, ideal for real-time communication apps. Monitoring and logging, integrates with CloudWatch for monitoring and logging. Understanding auto-scaling. In AWS, auto-scaling is a powerful AWS service that automatically adjusts the number of EC2 instances running in response to traffic demands. It ensures that the correct number of instances are running to handle the load while optimizing costs. Key features of auto-scaling: dynamic scaling, adjusts the number of instances based on real-time metrics. Scheduled scaling, scales your fleet based on predictable load changes. Health checks, automatically replaces unhealthy instances to maintain application health. Designing highly scalable architectures. To design scalable architectures, consider the following principles. Microservices architecture, break down applications into more minor, independent services. Stateless applications, ensure application instances do not store user sessions or data. Decoupling components, use services like Amazon SQS and SNS to decouple components. Database scalability, utilize Amazon RDS RED replicas and DynamoDB for scalable databases. Configuring AWS ALB for high availability. Configuring ALB for high availability involves multi-AS deployment, distribute targets across multiple availability zones to ensure resilience. Health checks, configure health checks to monitor targets' health and route traffic to healthy instances. Listener rules, define rules to route traffic based on content, ensuring efficient traffic distribution. Implementing auto-scaling groups. Auto-scaling groups, ASGs, are collections of EC2 instances managed as a group. To implement ASGs, define launch configuration, specify the instance type, AMI, and security groups. Set scaling policies, define policies for scaling in and out based on CloudWatch alarms. Configure health checks, use ALB health checks to ensure instances are healthy. Monitoring and managing auto-scaling. Monitoring auto-scaling involves CloudWatch metrics, track CPU utilization, request count, and error rates. Scaling activity, monitor scaling activities to understand when and why scaling actions occur. Alarms, set up alarms to get notified of critical events and threshold breaches. Optimizing performance with AWS ALB. Optimizing performance with ALB includes connection draining, gracefully handles in-flight requests during instance termination. Idle connection timeout, configure appropriate timeouts to manage idle connections. HTTP/2 and WebSocket, leverage HTTP/2 and WebSocket for improved performance and reduced latency. Ensuring reliability through load balancing strategies. To ensure reliability. Active load balancing, distribute traffic evenly across multiple targets. Active-passive failover, design failover strategies to handle target failures. Weighted target groups, route traffic based on weights assigned to target groups. Handling failures and scaling events. Handling failures and scaling events involves auto-healing, automatically replace failed instances using auto-scaling health checks. Warm pools, maintain a pool of pre-initialized instances to reduce scale-out time. Throttling, implement throttling to manage traffic spikes and prevent overloading. Best practices for scalability and reliability in AWS to achieve optimal scalability and reliability. Infrastructure as code, ISC, use AWS CloudFormation or Terraform to manage your infrastructure. Security best practices, implement security groups, IAM roles, and encryption. Continuous monitoring, continuously monitor and optimize your architecture. Conclusion. Ensuring scalability and reliability with AWS ALB and autoscaling is essential for modern applications. By understanding and implementing these tools effectively, you can ensure your applications are always available and performant. Thank you for listening to our podcast. Please share this podcast, visit our website and follow our social media links.